Honey, I'm a perfect 10. What does perfect even mean? Is there even such a thing? Ooh, can we switch up all the rules and imagine a utopia? Darling, I'm just so fed up with these expectations. They keep weighing me down. My heart is begging me to get the hell out of my head. I wanna live inside the upside down for a minute and pretend. Honey, I'm a perfect 10. Whoa, whoa. Honey, Honey, I'm a perfect 10. 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 Whoa. Honey, I'm a perfect 10.
All right, hello world, this is CS50 Live. My name is Colton Ogden, and today we're joined by the man himself, David Malan.
Hello everyone, good to see everyone on stream and not just in the chat today.
We are doing something pretty cool today, pretty fun. We're doing a from-scratch sort of Python tutorial, and my understanding is that you've actually brought some questions and topics that
let's call them challenges
for me to that I haven't seen, that we're going to implement, and I'm going to sort of be a proxy to somebody who maybe is learning for the first time.
Indeed. So I'm going to pretty much assume that Colton may or may not actually know Python, and so along the way we'll try to solve some problems actively via coding. We'll pull things up via Google or Stack Overflow as we go, and frankly try to approximate the experience that Colton and I arguably do every day when we're writing code to sort of figure out problems that we've not yet solved.
Sure. I guess maybe we should start off first off by maybe explaining what Python is. Because folks, we've advertised this as sort of an experience for people who may not have even programmed, or at least have not programmed in Python before.
Yeah, so why don't we assume that no one here is really that familiar with Python, but if you are, that's fine. Hopefully we can fill in some gaps in your knowledge. Stop us at any point via the chat if you have a question. There's no dumb questions here. If we taken for granted that you know what some concept is, or some function is, or some feature, just chime in and say, hey everyone, what did they mean by that? And so that we can answer here on stream. So Python is a very popular programming language. It's a little different from languages like C and C++ and a few others that you would traditionally compile. Recall that if you've ever programmed in one of those languages, you have to actually run some program called a compiler to convert your source code, the text that you write, to machine code, the zeros and ones that the computer actually understands. Nice thing about Python is that we don't have to do that. What is, you want to characterize Python for folks to distinguish it from that process?
Yeah, no, I mean, Python's nice. It's essentially, it runs almost in this, it's called a virtual machine, but it's almost like having a computer inside a computer. And it executes these, with a traditional programming language, you're writing text, and I'll switch over to my computer here just so that we can maybe frame this visually a little bit better, but not Chrome, I'm in VS Code. By the way, this is my text editor of choice. It's just VS Code. You need, in order to write any source code, some sort of text editor application. You could even use something like text edit. For example, if I pull up text edit on my Mac, it's, I'm not sure what that email is there, but I think that might have been from another stream. But essentially what you do is you have some program that you can write text into, and usually you don't want to write it in what's called rich text, where you have formatting. You write it in plain text like this, and you write your instructions to the computer, a bunch of lines, tell the computer what you want to do.
So is that Python?
No, this isn't quite Python.
That's not Python?
Not quite. No. Unless you don't know how to write good variable names, this might be some people's Python code. But you essentially go through and you write a set of instructions for the computer like this, top down, and the computer will execute them. But computers don't understand arbitrary textual information. The computer can only speak in certain languages. Specifically its own machine code, which is binary code, which we talk about in CS50. If you want to know the more underlying principles of that, David has an awesome series of lectures on our YouTube channel. But long story short, somewhere along the line you have to convert all your instructions into something that the computer can understand, and with a traditional language like you alluded to before, you do this with the help of a compiler. It'll actually take this text and end up translating it into, basically this, which is the computer's native sort of tongue.
But how's Python different here?
Python is different in that it doesn't actually perform this step explicitly. Along the line, it still actually happens, but it basically translates all the lines that you've written when you just load the script into a program that is itself called Python.
Yeah, and you can think of Python then as an interpreter, this sort of middleman that translates between what you write and what the computer actually understands. So you can think of Python, the program, which we'll run in just a couple minutes, is a program that reads your own code, top to bottom, left to right, and just does what you say. You don't have to actually use something like Visual Studio or GCC or Clang or any number of other compilers explicitly. All of that sort of happens for you automatically thanks to the interpretation process along the way.
Indeed. You can even fire up, let's say if you have it installed on your machine, for example, here I have Python 3. There's two different versions of Python 3. Long story short, Python 3 is the new way. It's the way that is going to be the official way very shortly as of 2020. But if I type Python 3 at my command line, assuming you have it installed, you can see that I actually have this sort of prompt here, these 3 arrows, and I can actually type in instructions, and it will immediately execute things. For example, if I wanted to say print David J. Malan like this, assuming that I type it correctly, it'll actually literally do it without needing to do that intermediary compilation step.
Yeah,
translation.
so this is an interactive interpreter, so it will just do what you say. The downside, of course, is that we're not really saving any of our work along the way, so it's better generally to write your programs in an actual text editor like VS Code or Sublime or Atom or something else so that you can save your code and let the interpreter run it and rerun it again and again. So why don't we go ahead and do that? Do you want to go ahead and open up a blank editor window? So for those of you following along at home, if you want to go ahead and Google VS Code or Visual Studio Code, you're welcome to download the same program for free. Atom, Sublime Text, and Notepad++, and a bunch of others are very popular on Macs and PCs and Linux machines, but odds are if you're tuning in, you probably have some form of text editor, but if not, feel free to try one of those. And then what you should also do, if you don't have it already, is make sure your computer, if you do want to follow along, has Python installed. So again, Python is not only a language, it's an interpreter, a program that will understand your use of that language. And if you go to python.org/downloads, you'll find yourself at the official website where you can download the Python version 3 installer to make sure that you have that on your machine. Depending on how your machine was configured, you may have Python already, as Colton said, but it might be an older version, Python 2. That's officially going to be end of life soon. That is, it's being phased out in favor, finally, of Python 3. So everything we do today is Python 3 specific, but beware, because when you're Googling, when you're looking on Stack Overflow, there's a lot of good answers to old Python code out there, so you don't want to be led astray.
Cyril has a sweet comment. Says, David, because of you, I stopped playing video games all day, learned to code. I now have a real job at an e-com company.
Wow, that's amazing. I see Andre's taking exception to the fact that we haven't promoted Idle. There's a few other IDEs and editors as well. This is not an exhaustive list. What's nice about things like VS Code is that they are first and foremost a text editor, and you can layer more features on top of them.
Somebody asked what VS Code am I using? I think I'm using Dracula right now. I switched to that at the end of the last stream, but I actually prefer the Noctis theme. So real quick, just the important stuff out of the way first.
This has nothing to do with Python.
We're going to switch to the Noctis color theme. That's the one that I recently have liked, but a lot of the defaults look very nice.
Nice. And do you want to, let's go ahead and get rid of the Explorer for now.
Oh, yep.
But let's just go ahead and save this program as hello.py. So hello is going to be the name of the program. Py indicates that this is a Python program. You don't need number 3 anywhere in there. You still just use .py. So our first program, well, let's keep it super simple and literally write the program that everyone in the world seems to start writing code in, which is just hello world. So instead of David J. Malan, how would you go ahead in Python and just write a program that prints out literally hello world?
Well, I would use the print function, which comes with Python. And actually, the nice thing about VS Code is that it gives you a lot of this sort of built-in IntelliSense, depending on how you like to develop, where it'll actually tell you when you write functions, sort of what the function expects, what it does. So this is a nice thing about modern text editors and integrated development environments, IDEs. And you said hello world, so I'm just going to type in the string hello world. And that's it.
Yeah, and you'll notice now that you get syntax highlighting with programs like this. I see there's a shout out to PyCharm as well, which is a popular editor for Python as well. Yes, we do know that IDO might come with the default installation, but we're just focusing on Python today. You can use any text editor out there that you would like.
And it's amazing, folks in the chat are actually typing some responses to what you said. And actually, this is kind of interesting because Gaurav Burjwal actually says, print hello world, and if I'm reading that correctly, he actually said, or he or she actually said, hello world. Now, if we try to, do you think we should try and run this and see if this works?
No, I don't know. I don't like the squigglies. That usually suggests that there's a mistake of some sort.
So, okay, undefined variable hello. And this says unexpected token world. Interesting.
Yeah. So let's come back to that though, because I think we should run the program first. Because while we have arguably written a program now, we haven't actually run it.
Okay.
Previously, when Colton ran the program called Python 3, he was able to write a line of code, hit enter, and immediately it was executed. But typically, the paradigm, of course, for writing code is to write one or more lines of code, save it in a file, and then somehow execute that file. So I think to execute this file, hello.py, we're going to need a terminal window.
Sure.
How do we do this?
So I already have one. So this is the Mac native terminal application. Windows has the same thing with CMD. Linux, I actually don't know what it's called on Linux. What's it called on Linux?
Terminal window or Xterm or a bunch of other things.
And so I'm still in the Python shell. I'm going to clear my screen. And then this is assuming that I'm actually in the directory where we're doing this code. So right now, We are at my, I believe, dev. Is it PWD that tells you where you're working? Yeah. So this is for present working directory. I'm here, users, jharvard dev. I want to actually go into where I just created that file, which is streams/Python tutorial. And I believe that is where I created it. And you'll see I hit ls for list. And then if I type in Python 3, like we did before, to open up the interactive shell, but instead I say hello.py after that, we'll see that it actually outputs exactly what we wrote in the source file here.
And while trivial, go ahead, if you could, go back to the terminal window and just literally run Python 3 hello.py again. This should go without saying, but because the code is saved in a file, you can, of course, repeat your steps. You can improve on the program. You can fix bugs again and again. Can't do that as easily in just the interactive interpreter alone.
You lose all that state that you've created as soon as you exit the interpreter in that context.
So the place we usually start when introducing Python to other students is to actually now make the program actually interactive. Like a program that just prints out hello world, while sort of nice to be part of that history for posterity, it's not particularly interactive at all beyond just running it. So how would, in Python, you go about asking a user for his or her name and then say hello so-and-so instead of just hello world all the time?
It's common in a lot of languages that you get some sort of input function. Java has one, you create a scanner at system.in. C uses scanf. And in Python, it's actually pretty easy. All you have to do is just say, let's just say I want to store the user's name in a variable called name. And then I'll assign it whatever the return value of this function input is. And notice that I'm still passing in this string hello world, because when I ask them at the command line, maybe I presumably want to prompt them for something. Or maybe say, in this case, not hello world, but please enter your name : space.
Okay.
And then if I run, let's try it out.
Let's go ahead and run it. So notice Colton's using some keyboard shortcuts. He's hitting up on his keyboard, which on a lot of computers will actually rerun the previous command, and you can keep hitting up, 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 up to go to previous commands further.
So I'm already realizing there is going to be a slight issue with this. So please enter your name. Let's say my name is Colton, and the program is over.
Nice.
Which is expected.
Yeah, I mean, you only wrote one line of code that is asking the user for input, prompting them for their name, and then storing that value over on the other side in the name variable. So what do you want to do next?
Well, now, since I have name actually stored somewhere, I've said name equals or gets the value of input, please enter your name. I can actually reuse that variable. So I can say print hello space, and then there's multiple ways to do this, which we might have time to look at, but for now I'll just say hello, and then I'll actually add name to that string like that.
Yeah, so what's this plus? I mean, we're not doing addition here.
No, so this is common in a lot of languages. This is a term called concatenation, where you're not actually adding numbers, you're actually adding strings. You're basically taking one string and sticking another string right at the end of it.
Nice.
And in the common operator for that use case, and there are multiple operators across different languages, but common is the plus, just because it's kind of intuitive.
Okay. All right. Well, let's go ahead and run this. It's now 2 lines of code. Colton has saved his file. He's going back to the interpreter and running it on this file, and we say hello, Colton.
Seems to work now. It's kind of a cold hello. If I wanted, I could probably add maybe a exclamation point at the end of it, just to make it a little bit more, I guess, inviting or friendly.
Or an unhappy face to see you.
Oh, true. I could say hello, Colton. There we go.
Nice.
Hello, Colton.
Now, unfortunately, that's going to print an unhappy face for everyone, not just Colton, but even me and for you. So why don't we go ahead and change this? I feel like in a lot of programming languages that we've seen, that folks out there might have seen, you can do things like conditions. You can do something if something is true, else you can do this other thing. So could we modify this program in Python to maybe be happy to see anyone except you?
Oh, okay.
In which case you should see the unhappy face.
Wow, this feels like a depressing.
Hey, this is what the audience is requesting.
Oh, is it? Okay, so we'll say we're gonna get the name, and then I want to basically check to see what the value of the name is,
okay.
Right? Because you said we want the frown to only appear whenever it's me, and otherwise exclamation point. I'm assuming.
Anything else, really.
Anything else, really. Okay, so we'll keep it simple. So I'll say if name is equal to Colton, colon. So this is a Python thing. If you want to do an if statement, you're going to
Colton, not colon.
Yeah, Colton, colon. Then we'll say print hello, and then we'll do plus name plus, and I guess in this case we could even hard code the name since it's specific to this use case. And then we'll do the frown. I'll actually put a space in front of the smiley face because it was getting put right on the edge of my
let's make
name.
sure we see how unhappy we are to see
Yeah,
it.
exactly. And then we'll just do this other, thing. If that if statement doesn't turn out to be the case, if the name is David or anybody else literally in the entire universe, then we'll just say else. We'll do what we did before, which is just print the name. And then in this case, though, we do want the program to be happy to see who it is.
Yeah.
So we'll do an
All
exclamation.
right, so let's run this, and then let's come back and we'll tease apart some of the syntax that we've just added.
Sure. So we'll say, first of all, we'll say David. So hello, David. So
Nice.
it seems happy to see you.
Very nice and polite. How about, can we do another one? Can we do, how about Richard? Hello, Richard.
Richard. Okay. So please enter your name, Richard. Okay.
Delightful
Hello,
to see you as well.
Delightful to see Richard. Now let's test to see if our functionality is correct. Our I guess one-off use case, and we'll use my name.
Oh, perfect. This is a good program so far.
We have a smart program that knows the appropriate way to address it.
Sort of, though. Can you run it one more time? And
Sure.
like an angry person, can you type your name in all caps this time?
Oh, sure, absolutely. So I'll say Colton. Oh, wow. So it is happy to see me.
No, this is a bug. This is objectively a bug. So maybe we're going to take a look at a couple other syntactic features, but especially if you're a little new to programming, but you have the right intuition here, if folks in the chat wouldn't mind proposing what techniques we could use to actually solve this problem, we'll go back in and fix it in just a minute or two.
Andre said it's a feature, by the way.
No, that's a bug. That's a bug. But let's go ahead and back to the code for just a moment while folks propose some solutions here, perhaps. And there's a few questions I had. For instance, if I'm coming to Python new, what's with the colons? Like, I'm used to the indentation, but the colons, and where are the curly braces?
So the nice thing about Python is there are no curly braces. The interesting thing about Python is that everything is based on white space. So indentation, like blocks, and this is something that folks may or may not be familiar with, but denoting that something essentially is inside of something else is done with indentation. So this if statements, like body of code that executes when it's true, we don't use curly braces like we do in other languages. We can inline it, but you would, instead of doing something like this, and then having and I'm not 100% sure. I think technically, is it technically possible to use? No, it's not. I'm getting that conflated with, I think, something else. But you don't need
another stream entirely, but moving on.
you don't need these things. All you just need to do is make sure this is indented a certain level within this, after this if statement here.
And now, without opening a can of worms, what's your preference? You like tabs or you like spaces?
I like tabs that get converted into spaces.
Okay, I'll take that as an acceptable answer. Indeed, in the Python community, unlike most languages, there is an accepted norm, or at least a recommended norm, which is to use spaces. So let's put an end to that debate today. We're going to use spaces. 4 spaces generally would be pretty common, but I like that. You don't have to do the curly braces, as you know. But I notice you're also using single quotes, and I feel like in different languages, and even in Python, I sometimes see single quotes, sometimes double quotes. How do I think about that?
So there are, for the large part, interchangeable. You can make strings with double quotes. You can make strings with single quotes. Now, if you're coming from a background like C or Java, you can only use double quotes for strings, but you have to use single quotes for single characters.
Okay.
In Python, there's no difference. There is not really a, by default, single character versus string when you're using this apostrophe character or the double quote character.
So how would people go about deciding whether I'm a single quote kind of person or a double quote kind of person?
Well, I think that's a matter of taste, but if your string, for example, contains, let's say, Colton's favorite food.
Pizza.
Well, we can see that there's an issue in that
different issue.
we see the green that we've seen before with strings after this apostrophe, up until this apostrophe where we're actually using it for grammar. We're actually using it as a part of the string itself. And there's a couple ways of dealing with this. One way is we could use the backslash like this, and that'll fix it. So now we've actually said, ignore this apostrophe, this is part of the actual string.
Yep, Gen X Hacks notes that as well, nice.
But let's say I don't like the way that looks, I don't like having a backslashes throughout my strings all over the place. Instead, I can decide, in any case where I do have a single quote inside the string itself, I'll use double quotes on the outside, and because this doesn't match up with this, it doesn't cause an error in parsing the string.
Nice. Yeah, and I'll admit I'm kind of going through an existential crisis. I've been using double quotes for like 20 years, and frankly, I'm tired of holding the shift key down. And I do think you're seeing in more modernly popular languages, Python and JavaScript among them, I'm starting to see, frankly, I think single quotes more often, but you got to beware because of the stupid grammar issues alike.
Yeah.
So I don't know. Just be consistent, I think, is the point, or resort to one or the other when you have to contextually.
I'm personally a big fan of single quotes as well. Don't like holding that shift key.
Yeah,
Too much work.
yeah, I know. Too much shift. 20 years of hitting the shift key is enough.
Somebody proposed an interesting way of getting around the problem, though.
Yeah, let's come back to that. I heard someone proposed that we use lower, so force the whole string to lowercase. I see Richard proposed using an array or a list in Python where we could check for little Colton or big Colton or alternating caps Colton. I think the downside there is that you're going to have an annoying number of permutations of Coltons, if you will, with the C is capitalized or the O or the L or multiple ones and so forth. So I like this lower idea, and this is actually pretty conventional in a lot of programming languages, especially Python. When you want to compare something for equality, you canonicalize it, so to speak. You force it to all lowercase or all lowercase or all uppercase so that you know definitively what you're comparing against. But you don't want to do it destructively. You want to do it essentially temporarily on a copy of the variable.
Right, exactly.
So how could we do that here to make sure that we are unhappy to see you?
Well, we could say, essentially, here's what happens. I guess we should demonstrate this in the terminal before we do anything else. So I'm going to pull up Python 3, and this is a nice thing. Actually, first what I'm going to do is I'm going to clear my CLI, and then I'm going to pull up Python 3. If you're ever curious about using a function in Python, this is the upside of being able to use it in an interpreter context. You can actually just fire up your interpreter and just test variables, test functions right away. And I happen to know that there's a function called .lower. It works on strings, but let's actually experiment with it. So if I say, let's do, for example, the string Colton, and we'll say .lower parentheses, and we'll hit enter. And we'll see that it indeed brings it all down to
Now this is weird.
lowercase.
Why do you have a period after a string? Don't you need to do that on like a variable or something?
So this gets into kind of the idea of what's called object-oriented programming, which we won't dive into today. But essentially, every string in Python has a series of functions that it has its own reference to. And the function, when you call it using this dot, which essentially means go inside of the thing to the left, and then execute this thing that belongs to that thing on the left. In this case, the lower function sort of belongs to this string Colton. It will run this function and sort of implicitly pass in this as a parameter to this function.
Yeah, so what you really have is that Colton is indeed a string in this case, and a string is an actual object, technically a class in Python. So it has all of these features built into it, just one of which is this lower function. So I see Hassan Ali proposed, I think, what's actually a perfect solution, and that's a little simpler and less code to write than something like the list-based approach. So should we want to deploy Hassan's approach?
Sure. So first, before we do that, let's just test it again. So we have the version where it's my name typed normally. Let's test it with the version of my name in all uppercase, which does also go to the name Colton. And then just for kicks, we'll do old MySpace style text, and then we'll
showing your
do
age.
that. There we go.
Okay.
And then we'll see that no matter what permutation of capitalization we use,
we are unhappy to see you.
yes, exactly. It all comes back down to the same base case. So I'm going to exit Python, and then we'll adopt what Hassan said, which was if name.lower is equal to not to Colton with a capital C, because that won't work. There will never be any capital letters.
You're
in
right,
.lower.
Hassan. I think Andre caught it there, but I misstated. We do have to make one tweak.
Which is just replace that with a lowercase c.
Indeed.
And if we run this, let's go back here and we'll do Python 3 of hello.py again, which I could have just hit up probably. And first we'll try it with my name like this. Okay, hello Colton. It's a frown. Okay,
Yeah.
so that was the behavior that was happening before. Let's try it again, but this time let's do just the first couple letters capitalized. Oh, but here's the interesting thing. It's actually okay. Never mind. It's still printing out CO. A nice feature would be to have it print out the name with just a capital letter and not the second letter.
Well, funny you should
capitalized.
say, because our next challenge is going to be exactly that. Suppose
man.
your user does mistype his or her name in some stupid way, like Colton did here, capital C, capital O, L-T-O-N.
Classic Colton.
We can, at least with some probability, fix this in code. Now, I say some probability because, at least in English, there's a lot of names that have a mix of uppercase and lowercase characters. O'Reilly, for instance, is a last name, also the name on a very popular series of computer science books you might know. So So we could get this wrong, but let's assume that we have very simple names, in this case like Colton, capital C-O. How in Python could you force the user's input to be neatened? Not all lowercase, but capital C and then lowercase Olton.
Well, my first instinct would be probably to use this name.lower as our starting point.
Okay.
So we'll bring everything, we'll canonicalize all the names back to all lowercase like this, and let's actually start with that. So we'll go name.lower, actually other way around. Well, actually no, we'll do it in both cases. We'll do it in both cases. So now you'll notice that I'm printing name.lower in the actual output for both situations where we've typed in a name. So that way, even if we type in capital C, capital O, LTON, it's still going to give us the canonicalized string. So
And not the best design, but we'll get there.
let's try this out. So we'll say this, please enter your name, and we'll try Colton like that. And it does indeed say hello, Colton, but
Right.
with everything lowercase. We're halfway there.
Yeah.
We still have to now do the very first string.
Okay.
And this
First
is
character in the
first,
string.
First character in the string. So I actually offhand don't know what function strings might have to capitalize the first letter.
But the chat does.
Does the chat happen to
But
know?
no looking yet, no looking yet. How would you do
I
this
caught
if you
it.
were home alone without a live Twitch stream to answer these questions for you?
Sure. So I would probably say Python capitalize first letter string. So have the name of the language as the first word, because that's probably going to be a major thing that Google optimizes for. And then just literally kind of the main words that I care about in the query for what I'm looking at, which capitalize, not, we specifically want the first letter in a string.
Yeah, and this is something you learn over time, and odds are most everyone in the chat room has learned this already. You don't have to ask Google or Bing or whatever you use full sentences. You can drop the words that really aren't adding anything to the query, like how and it and is, and really just focus on the words like Colton has here that really have more information content for the search engine.
Exactly. So I'm gonna do that query. And
Wow,
the
nice.
Google is amazing. The first result says, in Python, the capitalize method converts the first character of a string to capital letter, uppercase letter. If the string has its first character as a capital, it returns the original string.
Yeah, and I don't use this particular site too often myself, geeksforgeeks.org, but it seems on point. And just for kicks, can you scroll down just so we can see what some of the other search results are?
Sure.
So we're seeing Stack Overflow is number 2, Stack Overflow is number 3, a blog is number 4, programiz.com is the next. So you'll start to see patterns in search results. If you're learning programming or teaching yourself, Stack Overflow is a big one, but sometimes Google thinks that it's pretty sure it knows what the answer is, so it'll just bubble it up special to the top.
Cool.
All right, so let's try this, but shout out to those of you in the chat, Juban3 and Davis 216, all of whom got this, and Mage Drifat, if I'm pronouncing that right, also had a clever solution, but arguably you're reinventing a wheel, and I would propose that in Python, you really try to reuse some of the wheels that have been given, but odds are underneath the hood, Capitalize is doing something quite like that, but probably with some error checking, just in case name is short.
Indeed. So we'll say name.lower. Now this is an interesting thing. So when we call this method .lower, it's actually returning a string, a new string. And then that's essentially what we're doing here. We're returning a new string, putting it into the output. We're returning a new string and comparing it to the string Colton. So the cool thing is that you can actually chain these methods onto themselves. So I can say name.lower, which gives me the name Colton in all lowercase, or whatever name in all lowercase letters. But I can then do .capitalize, like so. And what this will do is this will say, okay, give me the .lower method of the thing to the left, okay, and return it. So this will give whatever the name is, all lowercase letters, and then this becomes essentially that. Then when you call .capitalize, it's doing the same thing. It's saying, give me the value to the left, and then capitalize its first letter. That thing to the left is now that lowercase string.
Now, when you hover over capitalize, based on the definition of this function that VS Code is feeding us here, do we need to force things to lowercase first? And how would you go about figuring that out?
Return a capitalized version of the string. More specifically, make the first character have uppercase and the rest lowercase. Ah, that's interesting. I actually didn't realize that was part of the signature. Well, let's try it then in that case. So let's say if name.capitalize, and in this case, I mean, we could even do it here and say Colton and then .capitalize. Let's try it out. So let's say the name of Colton first. Okay, hello Colton. Let's try C-O-L-T-O-N. Whoops.
Not a command. Now we have a whole new problem. How do we fix that problem?
We get better at using the terminal. Oh, it turns out that actually works.
Nice. So we saved a little code.
Python looked a few steps ahead of us.
Right, and so besides trial and error, like we just did too, you can certainly read the official documentation. In fact, just so folks can see it, if you've never seen Python's documentation, it's so-so. Like most of the information is there, but it's not always that easy to find what you're looking for.
Dave is not a huge fan of the Python documentation.
No, it could be much more user-friendly. So can you go ahead and find us the documentation for the stirring classes capitalized function?
Yep. So we'll go to str, which is the string class in Python, a string object type. And we went right here, string capitalize. And it looks like it's almost the exact...
pretty much verbatim. So VS Code's probably getting its instructions right from here. But this is good that we have the documentation up. And notice how it's ordered. You have on the left indented all of, left aligned, you have all of the function names in that class, boldface no less, capitalized, case fold, center. Someone in the chat just a moment ago proposed title. The title function. Is there a title function inside the string class?
Let's go ahead and look. There's is title, string.title, yep. So this is title case version of the string, where words start with an uppercase character and the remaining characters are lowercase. So this would be great for full names.
Yeah, assuming no weirdness with like lowercase letters needing to be lowercase still.
Sure.
But yeah, absolutely.
So we can maybe even experiment with that. So if I were to say, let's go back to VS Code. Let's say I'm specifically, maybe there's a Colton Jackson that we'd like to see, but Colton Ogden is the one we don't want to see. So why don't we go ahead and test that out? So we'll say name.title is equal to, because remember, title does what capitalize does, but to multiple words in a string. So in this case, we don't have just one word, we actually have two words separated by a space. So let's go ahead and say name.title and name.title. And there is a better way to do this, which we should probably also take a look at in just a second as well. So we'll go ahead and run this code. And I'm going to enter my name as Colton Ogden, but all lowercase letters.
Still don't like him.
Oh, it looks like it figured it out.
Nice.
It actually
smart
outputted
program.
the right name.
Is this artificial intelligence?
This is the seed for artificial intelligence.
Indeed.
State of the
Just
art.
6 lines.
State of the art.
Now, I would propose here too, we are using on line 3 title to compare against Colton Ogden, capital C, capital O.
Yep.
I'll admit, I don't love that. Maybe you can convince me otherwise. It just feels weird to not just choose something super simple like all lowercase or all uppercase, right? Because this assumes that now I have the sophistication or my colleagues know what title does, and therefore this just seems a little more fragile. Would you agree or disagree?
I think I would largely agree. I think I would say what I don't like the most is that we're using name.title, the .title method specifically in 3 places.
That for sure. But I like title for formatting, but for equality testing, personally, I would suggest you use something that's absolutely robust, all lowercase, all uppercase, or another technique altogether, but we'll get there in just a moment.
Sure.
I got another something good up my sleeve for you.
Yeah, well, .lower would probably be better.
All right, so let's change that to .lower.
Switch this to .lower, and then here's a nice little shortcut if you're using VS Code and you highlight something. Let's say I want to edit this and this, this at the same time. So I actually highlight this, and if I hit Command D or Control D on a Windows computer, I actually have multiple cursors. So now I can actually go over here and type lower.
That's amazing.
In 2 different places.
Typing twice as fast as I could have in my day.
There we go.
So let's take things up a notch if we can, because you have a middle name, right?
I do.
And a lot of people have middle names, and we want to make sure that we want to be unhappy about all Colton Ogdens, not just you specifically. So how could we go about adapting this program in such a way that it is unhappy to see Colton something Ogden or Colton something else Ogden, so that there's a Colton at the beginning and Ogden at the end? We don't care what's in the middle, but there can be something in the middle. How would you go about solving that problem?
Like a middle name.
Middle name, yeah, but one name, 2 names.
Arbitrary number of middle names.
I just don't want to see any Coltons over here or Ogdens over here.
Okay, sure. So in this case, what we can probably do is figure out, well, first of all, we're going to get input in a string of some kind, and it's going to be presumably space-separated names.
Okay, sure. I like that.
In Python, a nice thing that you can do is you can actually do this thing called split. You can split a string.
Okay.
So let's go into the terminal here and actually pull up the interpreter again.
I like this because you just want to play.
Yeah, exactly.
Yeah. Okay.
Let's just get a sense of what the function looks like.
And
And
indeed, in answer to the questions in the chat, yes, we're essentially at the moment just trying to get the first word and the last word.
Yeah. So let's say I have Colton Ogden here in a string, and I want to split it into its constituents.
Okay.
So I'll just do .split.
Which is another method inside of the string class.
Exactly. And, well, we have some interesting syntax here, but it looks like it did find my first name and it separated out my last name.
And what are these square brackets around you? Why am I seeing that?
So these square brackets are indicative of what you might have seen in Java or C in array, but in Python it's called a list. And the nice thing about lists in Python is that they can be of arbitrary size, they can grow dynamically, you don't have to allocate memory for them if you're coming from a more statically based background.
Yeah. And I'm smiling because the sandwich in the chat here is proposing that your sample middle name be Colton McLovin Ogden, which is a great reference to a great movie. Question here about can we use the in operator from Richard, because if the name is double-barreled, it wouldn't work. So in just tests for the presence of a substring anywhere in the string, beginning, middle, end, or anywhere else in between. So it doesn't feel like the right fit. We deliberately want to check the beginning and the end. So I think the road we're going down is at least one approach that we can take.
Yeah. And someone says stir.find as well, but again, I think that would also lead us down the same track. Assuming stir.find just literally finds whether...
and Notavision asks, what if someone has 2 plus middle names? That too we want to be sensitive to. So let's go ahead and... well, I don't dislike the approach you're taking, just splitting on the strings, but how do I go about checking for Colton at the beginning and Ogden at the end? And can we try like McLovin and maybe a 2-word middle name just to see what the result looks like so we know what to code for?
So Colton McLovin Ogden, which is fantastic. And actually you have 3. You have David J. Malan as your name. We'll use that as well. So let's split that. So again, it worked just like it did before. Even though we have 3 names instead of 2, it's split on spaces. So
can I see Colton. 4 names?
Let's do that. We'll see. David J. McLovin Malan.
Nice.
That's a mouthful. And we'll split that.
Okay, so every string from the original string ends up inside of the list.
It does.
So really we want to check the beginning of the list and the end of the list for Colton and Ogden and unhappiness.
We do. And lists are nice in that you can just reference, if you want a specific spot in the list, you can say, let's make a list here which has 5 numbers in it. Well, actually, for confusion, let's not do that. Let's say I have apple, orange, and banana as a list. And we could have just used our names as well. But if I want to get a specific element from the list, I can use what's called an index. And this is a numerical index. So lists start their ordering of their elements at 0. So for example, in this case, L at index 0 is apple. Index
Why is it not 1 if it's the first element?
Because computer scientists decided that 0 is how they like to start numbering things in most programming languages.
Okay.
Lua is 1 indexed.
Scratch is 1 index too.
Oh, do they? Yeah.
Okay.
Presumably for user friendliness, maybe. Because Lua, I know Lua was originally designed as a config language for less technical people, and Scratch is a programming environment for people that are fresh to programming and computer science.
But ironically, it just ends up confusing because then they eventually have to change the
they transition to C or to Java or whatever.
And now what's this?
0.
Is that a number 1 on the left?
No, that's an L, and L is just a shorthand in this case for a variable for list, L for list. And this is typically frowned upon. You don't want to use a letter as a variable name for most circumstances outside of maybe some context we'll get to a little bit later. But in this case, I just wanted a quick list, so I'm going to just use L again, and L looks like a 1 in a monospaced font. If I use these brackets, just like we did for the to actually show the list itself, but I say L at index 0. That's sort of how you can almost like a box. If we're thinking about it like there's little boxes, little cubbies for each individual spot in our list. If we do this, we'll see that L at index 0 returns apple.
Okay.
L at index 1 gives us orange.
Nice.
And then L at index 2 gives us banana. So everything is sequentially laid out.
And what fruit are we going to see at L bracket 3?
Ooh, that's a good question. It looks like Python is smart enough to know at runtime whether or not we're actually indexing outside of the range that we've allocated for our list.
Yeah, so in languages like C and C++, by default, you're typically going to see no error, but you're going to be touching memory you shouldn't, or the program could even crash if you do something like this. This, of course, is an exception. We'll talk about that perhaps in another stream, but it's a way of handling errors. And similarly, what is L bracket -1, for instance? Can we go to the left?
Oh, yeah, absolutely. So L bracket -1. Now, this would cause chaos, I think, if you did it in
Yeah, I'm really
C.
worried about this. This is going to break the computer.
Uh-oh. Interesting. So
Banana.
L -1 gave us, it looks like banana, the last element of our list.
Interesting. Now, why is that?
Well, it looks like, it turns out that in Python, you actually get this nice little syntactic sugar for indexing into your array from the tail and not the head, so to speak, the end of the list as opposed to the beginning. And starting at -1 and going backwards, -2, -3, you go from the end of the list actually to the front of the list, to the head of the list.
So what's L bracket -2 going to be?
L bracket -2 gives us orange, which is again one further from the back of the list.
And L bracket -3?
Oh. And indeed, it's
all right. So this is actually really handy when you want to do something relative to the end of the list, but you don't want to have to do all of the math yourself necessarily. You can just jump immediately to the end if you know the index. But the catch here is that I think when we go back to your text editor, we need to be robust against names with 2 words, 3 words, 4 words. So how can we go about modifying this program now in hello.py to check that the first element in the list is Colton, the last element is Ogden, but we don't really care how many other things are in between, because I don't think we can hard code 0 and 2 or 0 and 3. We need to figure out how many elements are in the list first, right?
Sure. So a first step would be, again, to break the string up into its constituent parts using the split method. So we can do that here. So we can say if, well, there's a few approaches we could do this. We could do names and actually take name dot split.
Nice.
And now we actually have another variable, not with the whole string, but with the individual names that make up the string that we passed in.
Okay, nice.
So now what we can do is we can say if names 0, because remember again, if we're indexing into our list at index 0, that's the very first element in our list. And we want to check to see if if the first name in the list that we've entered is Colton. That's what we care about. So we'll just say if names 0 equals Colton. And now, here's the thing. There are 2 conditions, though, because we could get a Colton Jackson, a Colton Smith, or what have you, but we care specifically about Colton Ogden. And so
the others are delightful.
There's actually 2 conditions here that we care about, not just one condition. And the nice thing that Python lets you do is actually say, okay, if I want to check for 2 different things, I can just say if something and something, then do something. If 2 things are true.
Okay, so you literally just say and.
You just say and. So I'll say if it's the case that names 0 is equal to the string Colton and names, if I can type, names at -1, again, the last element in the list, no matter the size, is equal to Ogden, then we want to probably not say name.lower, probably actually just say name dot, well, in this case, we would do name dot capitalized, names dot, what was it, title? I guess we could do name dot title, and then name dot title again for the actual printing out.
Okay.
And now the other thing here, though, is that if in this case we literally have the string Colton or literally the string Ogden, it'll work. But if we've mistyped, like we've talked about before, it's not going to work.
Yeah, I don't like that. So where should we do the lowercase trick, for instance, like we did last time?
So what we can do is I can say name dot, again, lower.
Oh, and force everything to lowercase initially.
Dot split, exactly.
So you'll get back a whole bunch of lowercase pieces now.
Yeah, this name, even with the spaces, all of the words, all of the letters that are alphanumeric, or specifically alphabetical, are going to be given their lowercase version.
Okay.
And so then after that, I can change. Now we're not comparing for the capitalized C, we're actually comparing for the lowercase because everything's been canonicalized again.
Nice. Okay.
And so then once we've done that, now when we render it, when we actually display the name, we don't want to display it lowercase because that'll look weird. Despite what they've typed, it'll look different. We want to clean it up. We want to give it the titleized version.
Yeah. Okay.
So let's actually try and run this now, assuming that I don't have any errors in here. Let me exit the interpreter, clear my screen, and then run my hello.py. So let's test it out. Let's say David J. Malan. Oh, wow.
Interesting.
It actually printed your name, and it's happy to see you.
It is.
Which is good. Let's go ahead and type, let's try Colton, we'll use my actual full name, Colton Taylor Ogden. Oh,
unhappy to see you.
Unhappy to see me.
What about Colton McLovin?
Yeah, what about Colton McLovin Ogden? Looks like it's still.
Oh, it knows it's you.
Still knows it's me. Now, what about Colton? Let's try Colton McLovin Smith.
Oh, he's fine. He's cool.
That's a different Colton.
What about just Colton?
Okay, let's try that. Hello.
This was suggested in the chat if we just have one name.
Oh, it looks like it's happy to see me.
Interesting, because it really is the Ogden that we don't like.
Correct.
Interesting.
Colton could be any Colton. And specifically, if your string is 1 element long and you do -1 and 0, these are identical. You get the same element because your list is only one size. So from the bottom and from the front, it's making the same steps to get to the same value.
And I see Asli_T asks, can you also do name 0 lower? You can, but then you're going to end up calling lower in 2 places because you're going to do it on names bracket 0 and names bracket -1. It's not wrong. It's just you're literally calling the function twice as many places as you need to. So I like what Colton did by elevating it to this other temporary variable, the pieces that end up in the names variable as well.
This is where you get points for for design specifically. Would you bucketize this as design? This would be design, right?
Yeah, this is design, I would say.
Style would be more about the indentation, whether your variables are named correctly, but design is like the actual how you arrange your function calls and sort of mold your data to accomplish the task at hand.
So I think if folks are comfy, I think there's a nice opportunity here, even though the program is pretty small, to kind of take things to the next level and introduce a more advanced topic known as regular expressions.
Okay.
Regular expressions allow you to check for patterns of user input, which is nice because what Colton something Ogden really is, it's a pattern. And we're being very deliberate right now in splitting the string on space, checking the first for Colton, checking the last for Ogden. But it turns out there's a general purpose tool via which you can just do this by expressing yourself in terms of a pattern and not really getting into these lower level implementation details of splitting a string and checking this and checking that. Would you mind walking us through an alternative solution that uses regular expressions instead of split and these equality tests?
On the heels of that, Davis216 says, oh god, not regular expressions.
No, here we go, Davis. These are great. They're great. You're going to build them up for step-by-step, baby steps, if you will.
So I know that in Python, Python ships with a module called RE. And a module in Python is just a library that you have access to. Well, specifically the module in Python is a folder with a specific file in it, but modules, as they're commonly known in Python, are just libraries that ship with the language itself, part of the standard library. So you can do something at the very top of your program like import RE, RE being short for, of course, regular expressions.
Regular expression.
I might have to refresh my memory on how to actually use this library because it's been a little while, but this is why we have Google here.
Point Malan.
But RE, a regular expression is pretty cool. It allows you to actually specify sort of a string pattern, a grammar, so to speak, for what you're looking for, how you want to actually parse your string, extract data from it, test whether it fits some kind of, not hard-coded, Colton Ogden, but whether it's something a little bit more complicated. Mm-hmm. So in this case, how do we want to do this? We want to use RE just to test for Colton Ogden, or?
I want a Colton at the beginning and Ogden at the end, and I'll take anything in between, and I don't care about capitalization. Take it away.
Okay, sure.
Now, we should note, there's a little bit of nervousness in the chat, and that's fine, and I do think you'll find that once we introduce this sort of piecewise, little bit by little bit, honestly, you'll find these pretty straightforward and pretty powerful. With that said, sometimes they get crazy complicated, and literally a day or two ago did I email a colleague saying, hey, how do I express this in a regular expression? Because even I get rusty on it sometimes. But we're going to take it slow and make this pretty compelling.
Yeah, you said there's nervousness in the chat. There's a little nervousness here in person. I'll be honest with you. But we'll figure it out.
It's okay. This is a judgment-free zone. Over here, notice.
So there are a few functions that I know that exist in RE. And you can do what's called compiling a regular expression, where you actually create an object that takes in a regular expression string and sort of creates an object that you can then use to do matches more efficiently down the line. Alternatively, you can do something called re.match, which doesn't take a compiled regular expression, but just kind of does it a little bit more on the fly. This is based on my memory. I could be wrong. We'll find out very shortly. So if I say, so right now we're getting the name, so please enter your name, and regular expressions are nice in that you actually don't need to test for .lower in this case.
No, you can express that differently.
Yeah, you can use a regular expression actually to say, hey, regardless of case, does this match Colton Ogden? So actually, I'm going to get rid of this .lower. I'm actually going to get rid of split. And I'm actually going to get rid of names altogether because we're not going to need a list. And I'm actually going to get rid of this if statement.
This is what's getting cool. I mean, I know there's some nerves there, but this program is going to actually end up being shorter using a regular expression.
Now, I'm going to start using this function called re.match.
Okay.
And it looks like this will try to apply the pattern at the start of whatever string we pass into it. So it's going to take a pattern, an re pattern, a regex pattern, regex being short for regular expressions. So I'm going to say if re.match, and I'm going to use this an R string, which is just a regular expression string. It actually will syntax,
raw string, technically.
Raw string, and it will format it a little bit differently. It'll actually show you things a little bit differently. And now I'm a little rusty with my regular expression syntax.
C O L.
But I want to basically do C or C, and then Olton space. Actually, and I think I might be misremembering space. It's either that or that. I think one of the two is the opposite.
There's some deep breathing in the chat, but if you're in the chat and you know a little bit about regular expressions, by all means chime in here and paste your ideas. You can do this in bunches of different ways, and we'll give you one or more along the way here.
So, and then what we want to do actually is say plus for an arbitrary number of spaces. Now, this might not be the correct character. I'm going to try it here. So let's just run it, and then if this is wrong, we'll do a little bit of googling. And
I forgot he can see it when I make faces at the camera there.
If it's right, we'll go to a website that I like called regexpal. Okay, so please enter your name. Let's say Colton Ogden. Oh, missing one required position. Oh, okay, we have to actually do it on the string itself. So we need to say name. Okay, let's try that.
So you're going to match this pattern on the left against this variable on the right.
Right, correct. And then let's do that. So let's say enter my name, Colton Ogden.
Hey, it's unhappy to see you.
It worked. Okay, well let's make sure that it actually still works for other use cases. So let's say Colton Taylor Ogden. Oh, it's happy to see Colton Taylor Ogden. You know what I'm realizing is that all we did was we just said check for an arbitrary number of spaces, not for characters, other characters. So that is kind of a problem. So what I probably want to do is say, how do we do this? I guess we could just use dot plus.
Okay.
And then dot essentially means any character, and we'll see if that works. Let's try that out. So we'll say Colton Taylor Ogden. Oh, it looks like it's working now.
Interesting.
Okay, but what if we okay, let's try David J. Malan. Oh, it is happy to see you. Okay.
Interesting.
Did I mess up? Is there?
Well, what about a 4-person name?
Okay, let's try it. So let's say hello.py Colton McLovin Taylor Ogden. Looks like it's indeed unhappy to see me still. It knows it's me.
How about Coltonoscopy Ogden?
Oh, yeah, that's going to be a problem, isn't it? Okay. Coltonoscopy Ogden. But see, the thing is, people know that that's me still.
Yeah, but I want a Colton at the beginning and an Ogden at the end, not a Coltonoscopy. So there's a bug here, right?
Okay.
It's being a little too generous, and it's looking apparently for Colton and then anything else, but I want there to be a space there.
So what I want to do is I want to have at least one space and then an arbitrary number of characters.
Okay, backslash S means any space, so like space bar, tab, other things too.
So let's try that. So we'll go here, we'll try my name as normal, Colton Taylor Ogden, which it's unhappy to see me, and then Coltonoscopy Ogden. And it's still happy to see me. Okay. What is the...
No, right.
That's good.
I am glad to see Coltonoscopy.
Okay, I got a little bit...
What about... let's try one more. How about Colton Mogden?
All right. I do need to have a space before the O as well. Okay.
Colton Mogden I'm cool with.
That's my
So that should
my
not
evil
be
twin.
an unhappy face.
Okay, so what we need to do then is do again, there should be a space before the O. And I guess I should have explained before too here, this C bar C just means one or the other. That bar just is like an or.
And I'm going to need to correct you on that, though, before long. We can either do that now or come back to that, if I may.
Yeah, if you want to do it now, let's go for it.
All right, so if I can just interject with some my elder wisdom here. So the square brackets here and here denote what's called a character class in a regular expression, and that is a set of one or more characters that you want to treat either of. So in this case, the vertical bar, unfortunately, is not necessary because this expression here will literally give you a capital C or a C. That's indeed the role of a character class.
If we did it this way, we'd want the bar, right?
Yes, but then parentheses around it so that it's C or little c.
Like that.
Exactly.
Okay.
So that would work as well, but I think we should fix it for the Ogden as well in the end.
The Ogden. All right, we'll do it like that, and then we'll do it like that.
I like that now, but I think per some folks in the chat here, we're trying to handle some number of names in between Colton and Ogden. So the pattern really is Colton, one or more spaces, maybe one or more other words, then maybe a space, then Ogden. So it's getting a little complicated now, and I can appreciate this is where some of the pain goes. So
I guess we didn't also cover the caret and the dollar sign.
No, we can stall and go to those now instead if you want.
Yeah, those are probably the easiest part of the whole thing.
Okay.
So the caret just means the string has to start with this.
Okay.
And the dollar sign means the string has to end with this.
That's true, and can I interject with my older wisdom?
Anytime.
The caret symbol, confusingly, is not necessary here because the match function in Python
Takes it as the first,
checks
yeah.
from the beginning. But so let me propose this. Let's use re.search, which is slightly more
right.
general purpose. And don't worry about getting hung up on those details for efficiency reasons. They can actually be a good thing. But in this case here, now we have a general purpose tool. The caret says start the string, dollar sign says end of the string. And now we just need to get everything right in between.
Colton's hair says, I thought I wouldn't have a headache today, but here we go. Thanks, David.
Okay, but again, notice what we're doing. We're taking baby steps toward getting it right, a little more right, a little more right, and then hopefully 100% right. So what we need to express in the middle, it seems, is optionally a word and a space again and again and again and again. So how could we do that for folks?
So if we do, so essentially replace this dot plus. Is
Yeah,
the goal.
that feels a little too lax because dot in this case is not a period. It means any character.
If we want to do a period, we would have to actually backslash escape it.
Exactly, but that's even worse. So let's not do that.
Okay, so we know that we're going to have a space, then we're going to have after the Colton, and then a space before the Ogden, and between that, an arbitrary range of words.
Okay.
So I'm going to say we'll do well, in this case, also possibly an arbitrary number of spaces as well, if we want to accommodate possibilities.
Okay.
And so we'll say, if we're not going to use the dot, essentially the wildcard thing, we want to accommodate that, presumably. Now, what you talked about before with character classes, we can actually specify a range of characters using this syntax, where we say A to Z capital, A to Z lowercase, 0 to 9, which means all numbers, and this just means all characters from A to Z capitalized, all characters from A to Z lowercase, and all digits from 0 to 9. And I'm guessing there's probably even a simpler way to do this with the dash, is it dash W? Or
Slash W would be a word character, so
Right.
it would give you the letters of the alphabet in that case.
Would we want to do something like that?
You know, I'm okay with using dot to just represent any character, just because I think that'll keep it simpler, but we can make it more precise if you want.
Okay.
But so dot something
So
is
it would be
on
dot
the right track.
plus, and then a space, and then this whole thing really should, well, I guess it would go, would it go into square brackets? I'm not actually 100%
I think
sure.
you probably want parentheses.
Okay, we'll use
because you can use
parentheses.
parentheses for grouping. You use
Okay.
square brackets for character classes, a finite number of characters that you want to expect.
And then would this itself, or no, and then a space, and then this in a bracket, and then that with a plus. And actually, this, not that.
Okay, and let me propose we can simplify. Get rid of all the brackets in the middle there. They're just not necessary.
Okay.
So what I'm seeing here is this. If I can read this from left to right, we want start of the string, then give me a capital C or a lowercase c,
Right.
then give me O, L, T, O, N, then give me one or more spaces.
Right.
So even if you're getting a little overwhelmed right now, just take a step back and consider, okay, I understand like the first third of the regular expression. So now we're saying in parentheses the following group. Give me any character one or more times followed by a space, and I like that. And then you're saying here with the plus, whatever I just had in parentheses, allow me one or more of those. But you're currently therefore requiring a middle name because plus means one or more of these
Right,
things. So how can we
yeah.
say 0 or more of those things?
Oh, actually, offhand, I don't know. We might have to consult Google for this.
Okay.
So regex 0 or more.
Reasonable search query.
Okay. 0 or 1. Oh, this is 0 or 1. That's not what we. That's
Not
not
quite.
What we
So
want.
sometimes the first hit is not the best. Thanks, Google.
Okay, let's try this. So.
Wrong language, but it's probably going to be relevant because
Yeah.
languages tend to use the same syntax for regular expressions.
Okay. Match through. Okay, then that's for a range. Let's see. 0. Okay, here's 0 or 1. Oh, here's star is 0 or more. Okay. So
And that effectively makes it optional some number of times.
So then we don't need this plus anymore. We instead want this star.
Correct. And now the only thing I would be a little careful of is this. Strictly speaking, we could have that there, but I don't think we need it because if we instead just say give me one or more spaces after the optional middle name, that should offset it from your last name.
Right.
So if we recap, and this is what I would do when making my own regular expressions, because honestly, it's getting confusing. So you want to just break it down again. So this says, start at the beginning, then give me a capital C or a lowercase c, then an OLTON, then go ahead and give me one or more spaces to separate it from everything else.
Right.
Then go ahead and give me optionally 0 or more times the following stuff. The following stuff is any character, one or more times, followed by one space or more spaces. But that whole thing is optional. So what the parenthesized expression really represents is optional middle name, middle name, middle name, middle name, and it repeats. And someone commented in the chat earlier about your theory class being germane. If you've ever drawn out on a whiteboard or a piece of paper DFA, a deterministic finite automaton, or an NDFA, a non-deterministic finite automaton, the picture you're drawing that has loops like this, that is what the star is doing. Give me one or more of these again and again. Now that if you follow that okay, then at the very end we just have some Ogden. So that means give me a capital O or a lowercase o, then a GDEN, end of string. So again, crazy complex when you look at it at first glance, but break it down into those constituent parts, and I think it'll pop for you as well.
So let's test. Let's actually make sure it works. So we'll say, hello, Pi, please enter your name, Colton Taylor Ogden. Okay, looks like it works.
All right.
Always satisfying when we spend all that time.
I'm a little
working on
nervous.
something.
I don't think we should test anymore.
David J. Malan.
Nice.
Happy to see you. Okay, let's try a situation where I just have no middle name. Okay, still works.
Nice.
Okay, and then if we try, let's say we try 4 names. So McLovin, Taylor Ogden. Looks like it still recognizes this.
So what Colton's doing here is an example, of course, just manually testing his code, trying a bunch of inputs. Once you get more comfortable with programming, can you use various tools to automate this testing? So Colton or someone would still have to think about all of those different examples, but you'd save the tests in another file and then run some automated process that would constantly run those sample inputs against your program to make sure that you haven't messed up and created a new problem.
Oh, someone actually says try only Colton.
Uh-oh, I'm a little nervous. I'm okay. Colton's cool because we don't know if it's the one we don't like.
Right.
What about though Colton Ogden in all caps, if you could?
Oh.
Someone who's yelling. They really just are yelling your name.
There we go, Colton Ogden. We didn't account.
Well,
oh,
we didn't account for that.
Oh wait, no, we didn't. No, we didn't.
I am not pleased to see that Colton Ogden either. So how do we fix that?
Yeah. So here's the thing. What we want to do is get back into lower casing things. We want to go to name dot. We could do it that way, or we could
I think you read my face there.
Yeah.
I'm pretty sure we could do this with regular expressions, though.
Yeah, we probably could. So we could just do the same thing that we did before, which is not that. We do, I guess by default, because I have that string highlighted, that's why. So if I go over here, do an OO.
You could just have a whole bunch of character
LL.
classes, one for each letter.
There's probably a more efficient way to do
But
this.
dear God, this looks scary. It's kind of cool though too that your name is like duplicated this way.
Yeah.
So you could do this. This is correct, but I would argue bad design. Why? Because one, it's just so damn hard to read now. It's just making the string so much longer, and we're not even done with the Ogden yet. So I would propose undo all that. And it turns out there's a way with RE search and also for that other function, RE match, to tell them to match your pattern case insensitively. So how would you go, if I told you as like your tutor, like this is possible, how do you go about solving a problem like that now on your own?
Okay. So I would go into Google and I would say, okay, Python, RE,
Professor Google.
search, case insensitive. Without RE-compile, because we're not using RE-compile, so this is Stack Overflow.
That on another day.
Stack Overflow is an awesome resources, and it looks like it says, pass re.ignore case in all capital letters to the flags parameter of search, match, or sub.
Now what is this flags parameter? How do I look that up?
So if we go over to the documentation, actually I think we have the documentation tab open over here already. Scroll to the very top, get rid of this, type in re, do that. Go into the module for re, which is the module we imported. And then I'm using the search function. So I'm actually gonna type re.search. And let's go to where it's actually defined. So it looks like it's defined right here. So it does say we have a pattern as the first parameter. We've talked about this. String that we actually want to search inside of as the second parameter. And then this flags equals 0, which is interesting because we're not passing in a number, at least not that we can see when we're doing it, presumably.
You're not, but the equals 0 means that that argument called flags has a default value of 0 no matter what, so you don't have to provide it.
And truly underneath the hood, all of the RE dot capital words that we could pass into it are actually numerical, and they form what's called a mask or a bit mask, a sort of a sequence of powers of 2 added together in some arbitrary way to set a series of flags in one compact piece of information. And in here says, where does it say? It doesn't look like it actually has any information on flags itself.
Not at that part of the documentation, but it's in there.
So we go to flags.
Oh, you had it on the screen a moment ago.
Oh, did I?
I saw re.multiline.
re.multi. There we go. Oh, here are all the flags. Okay. It looks like they kind of have it separately from everything else. So these are some of the flags. So actually, are some of these flags or some of these just completely other variables?
No, the capitalized ones are all flags.
They're all
and,
flags. Okay.
I don't know how to pronounce this one, but the Van Lackum proposed adding the flags ignore case, and that's spot on.
Yeah. In this case, re.ignore case, more specifically, unless we wanted to import star from re.
Indeed.
So let's go back to, well, actually, I don't know if you wanted to talk more about what they are, but essentially, ignore case. There's multi-line, which will let you test regular expressions that span lines, and then there's ignore case, which will perform case-insensitive matching expressions like A to Z,
nice.
like we looked at before.
So we can just disable the notion of case altogether without having to manually force things.
It'll match lowercase letters. So actually, that means that we can get rid of this. We can actually just say Colton like that, and then Ogden. And then as our last parameter to re.search, we can say re.ignore case as follows.
So it's a third argument now explicit. So that's going to tell re.search, don't even worry about uppercase or lowercase for this match.
Exactly.
All right, so let's go check on Colton Ogden in all caps. In the meantime, Richard pointed out that we didn't account for Colton Ogden one word or a few other variants. That's okay because I was looking for a Colton, then one or more spaces, then an Ogden, not the concatenation thereof. A Colton Ogden one word would slip under our radar.
Yeah.
Ah, I'm happy to see you yet again.
It works.
Nice.
This is the nice thing that RE sort of makes life easier for us.
Yeah, so it's pretty intimidating, honestly, at first glance, but honestly, do not shy away from these. They will tighten your code. They will allow you to check for things more robustly. We could go down even further here and be more precise as to what we mean a last name is. Currently, we're being a little lazy, and we're allowing things like dot, which is any character. So just for kicks, can you go ahead and do Colton 123 Ogden? As a test case?
Sure. So
you know, we probably shouldn't tolerate this because at least in the US, you're not going to have like a purely numeric middle name, I think. I don't think so. That probably is not you. So that doesn't really meet the test. So dot star is a little sloppy. We could be more specific by specifying with character classes what letters of the alphabet we want. But we do need some punctuation, right? There might be hyphens. There might be quotes. In other languages, there might be accented characters. So we need to be a little respectful of the possible variation. So right for now, I'm okay with dot star. But you know what's kind of cool too? Could we go ahead and could you copy your regular expression from the caret to the $sign? And there's a bunch of websites that do this. Can you go into Google now and search for like regular expression tester? There's some really cool web-based applications that help you learn this stuff these days. Let's try Regex 101. Let's try the first one. Yeah, this is one I've used before. So Colton just went ahead and pasted at the top of the page the regular expression that he came up with. On the right-hand side, you'll see that there's this explanation, which is a machine-generated, human-like summary of what it is. Sometimes it can get a little confusing, but that might help you wrap your mind around it. But what's cool now is go ahead and input it like a test string. Give us a normal Colton Ogden.
Okay.
And you'll go ahead and see, let's see, where's my test? Go ahead and save the regular expression. Top left over there.
Oh, I think that makes it a shareable
that'll let us
link.
share it.
Do we have to do this stuff?
Nope, that's not necessary because it's already there. Nope, don't need that, and don't need the slash. Actually, can you scroll down? It might just be that the page is a little
you know
short.
what we probably haven't done? We probably haven't done ignore case. There's probably an ignore case flag on here.
Right. I don't know. Oh, yes, we can do that. Click on the flag.
Modifiers, ignore. Where is
you can click ignore.
Right here.
Yeah. So you can just add an I after that. So in other languages, you actually specify these lowercase symbols, not the Python approach. That makes it force it to lowercase. So notice this. On the right-hand side here of Colton's screen, you'll see that it's saying match information, and Colton Ogden is indeed a first full match. David J. Malan is not, so we're not seeing anything else. Do you want to try a few other of your cousins?
Sure. I don't have any cousins named after me, but we'll try Colton Taylor Ogden. Okay.
Nice, another full match.
And it actually pieced out the middle part here because it's in parentheses.
It's pretty cool. So if you want to learn regular expressions, you don't have to like struggle with your own code. You can just kind of play with it a little more visually. And I've definitely used this tool in recent years, especially as my regular expressions get long and complicated, because I want to vet them against sample inputs outside the context of my code.
Okay. And then if we do Colton 123 Ogden.
That's
that
gonna well, no. If we scroll down, I think.
Oh, you know why? Because I specified the A to Z here.
Oh, in this case, you did indeed.
Yeah. So
yeah,
if I go back to, if I go back to dot plus
and get rid of your character class
space
as unnecessary.
Plus. Oh wait. Oh, this right.
Yep. And no, you have duplicate space. Yep.
There we go.
Nice.
Oh, but it looks like it's getting your name as well. What did I miss up there?
Now here you have Colton space.
That's weird.
Oh, you're doing multi-line. Get rid of the M from the flags. Oh, in global. Sorry, not multi-line. Global.
Did I mess something up?
Colton. No, something's wrong. Can you scroll down over here on the right?
Weird.
I think this is a bug. It should be not matching. It should go ahead and update the regex just for kicks, even though that's under save and share.
Oh, update regex?
Just for kicks. It should not be matching multiple lines like this.
Did I? Yeah, that's very strange.
No, I think that's a bug in the tool.
Oh, okay.
Something's wrong.
Well, anyway.
Whew, okay, on that note, well, let's go ahead. I think we have a little more time to introduce one or two more features. Right now, our program is pretty static. It just does one thing and that's it. If we wanted a loop, you know, I'm kind of fond of the old games like Zelda. You and I have played that on stream, actually, the original Zelda.
Right.
And it's very common to have like heart power, HP, so that you have some number of hearts representing just how much health you have. Let's go ahead and start from scratch in a new file called hearts.py. And can you just write a program that asks the user for a number and then just print out that many hearts using a Unicode character?
Sure.
Unicode's pretty cool because you can express emojis and other things these days, but if you want to use ASCII-based hearts with like an open bracket and a 3, that's totally fine too. But let's just go ahead and whip this up. Ask the user for a number, then print out that many hearts for him or her.
So I'm Googling for heart in Unicode.
Okay.
I want to get the character. And we'll use this one. I think that should work. Let's try that. So we'll say heart char equals this little heart character. Notice that Unicode renders nicely in VS Code. And we'll go ahead, and now here's what I want to do. I want to essentially take the number. I'm going to get a number as input, and I want to basically multiply that number times this heart and print it out as a result.
Okay.
We're taking a number and actually applying it to a different string.
I like what you're thinking, but before we go this clever route, could you do it a little more familiarly to folks using like some kind of loop?
So I would say for I in maybe the range of num, so for every I that exists in num, which is going to be if it's 5, it'll be 5. It'll happen 5 times. If it's 10, it'll happen 10 times. And then let's print heart char. We'll do this approach for now. There's a few issues that we have here, but we'll see what happens when we run it. So I'm going to do hearts.py. Please enter a number. Okay, I want to see 5 hearts on the screen. Ooh, interesting.
Ooh.
So it says stir object cannot be interpreted as an integer. Interesting. And
now, how do you know what line is the problem?
So it in the stack trace, or the traceback, it kindly tells us that on line 5, on this for I in range num, it's saying that the stir object cannot be interpreted as an integer.
Yeah, so these error messages, frankly, early on are going to look pretty scary, but if you just start from the top, especially if you get a lot of errors, start with the first one, look for the line number, and then honestly just try to wrap your mind around what words you do understand and see if you can deduce then, like Colton's about to, where the problem is.
Exactly. So I know that num is what I'm using here. It's basically, it's what I'm inputting at the command line. And the thing about input is that it'll always return a string, literally what you typed in a string format.
Because they're just characters on your keyboard, even though they happen to look like numbers.
Exactly. Now, the thing is, I want this to be numeric. I want to be able to iterate over this number. I want to do something x times.
Okay.
And the way to do that is we actually have to convert that string into a number. We have to actually say in Python, int of all of that stuff. And what happens is that this input value of please enter a number, the string gets actually passed to this int function, which just takes in a string and returns you the number, the numerical version of that same string.
Yeah.
So string 5, you get back the number 5.
The number 5, the int 5, if you will, the integer.
Correct. So let's try that. So parse.py, I'm going to say number 5, and okay, it works.
Nice, but it doesn't really look like heart power because most games have it like horizontal.
Yeah.
Can we fix that?
Everything
even
is
though I wasn't
horizontal.
specific?
Yeah. So this is a nice, easy thing to do in Python. So this is a feature of the print statement. It's a feature, generally speaking, or a bug, depending on how you look at it. But it's specifically a feature because often you want to print something on the command line, but you don't want to have to manually specify that I want this input, this output to go, to do a new line every time. Because that gets a little bit tedious. And in languages like C and Java, you have to specifically, well, not as much in Java, but in C, C++, you have to specify this yourself. So if I want to say, just write this on the same line, but don't do a new line, print has a second parameter, and you can actually see it here written out. There's a sep, there's end. We care about end specifically. Notice that it has an equal sign, meaning that you can actually identify that argument. It doesn't have to go in a specific order as long as you give it a name. So if I say end equals, and then just the empty string.
So nothing.
By default, that's a new line character. By default, it's this \n. But I don't want to do a \n at the end of print. I want to just nothing, empty string.
And honestly, this drives me nuts about Python. Like, granted, you don't always want a new line character, but this is so annoying to type.
A print line, yeah, print versus a print line function might be cool.
Yes, I agree. Java got this a little better, even though redundantly.
Except in Java, you have to do system.out.println. But
it's just ugly.
Yeah, let's go ahead and run this now, and let's say 5. Oh, okay. So I have my 5 hearts, but it looks like as a byproduct of how we've coded things, now we don't go to a new line when the program is finished. We just end right after the hearts.
Well, that too, plus all your hearts are overlapping. But I think that's a function of you're using this Unicode character in a monospaced environment.
Yeah, it's a very small character.
But can we have a space after every heart?
Yeah.
Could that clean this up a little bit?
Absolutely. So all we need to do is say sep equals space.
So separator, yeah.
Separator. And then at the very end of all of this stuff, at the very end, I'm just going to do a print.
Okay, outside of the for loop, though.
Outside of the for loop, because otherwise we'll get the same behavior that we got before, which was that it printed everything on a new line, which was not the behavior we were seeking.
Jenka's from Russia. Hello from Cambridge. This is not PyCharm. This is just VS Code, a free text editor.
So if we enter a number 5, oh, and it turns out that didn't work. Is maybe sep not what I'm thinking it is?
No, it is. I think this is an issue of ASCII. You know what? Let's go ahead. Instead of printing out the heart char that you have, can you change it to an angled bracket and a 3?
Sure.
Let's do it old school style.
Let's do it that way. Please enter number 5. Oh, still didn't print the space.
Oh, you know what? Because you're only printing one piece at a time. So you actually do...
Here,
you can change
we'll
the
this.
ending to be a space.
We'll do this.
This is not how you solve problems.
and then we'll bring back our heart character. We'll see if that actually fixes it. So we'll copy that.
Separator would work if you were passing in multiple inputs, like a list that needs to be printed or such.
Oh, I see. Okay. Well, then there is a way we could do that. Now let's go ahead and we'll do this again. Enter 5. And there we have nicely printed out the 5 hearts.
Okay, very nice. Now, you started, I think, to go down a pretty sophisticated road that might be unfamiliar to a lot of folks. Do you absolutely need to use a for loop like this, or is there a more Pythonic way to do this?
There is a more Pythonic way, and this is something that's more specific to the way Python handles strings. Python has actually overloaded the multiplication operator. So in the same way that it's overloaded the plus sign to allow you to add 2 strings together end to end, it's actually given you the ability to use the multiplication sign, the asterisk, which we haven't actually looked at yet, to allow string multiplication. Now, normally it's not a thing in the real world, but in Python, what that essentially does is it just outputs that string x times, depending on what the multiplier is.
Correct.
So if we say, let's say, instead of what we did before, let's actually print heart char times num. So we're actually multiplying this heart string by the num that we've converted into an integer up top. Let's rerun this and enter 5. And we get the same behavior, unfortunately, that we had before. Now, there is another way we could do this if we wanted to use what's called a list comprehension. I don't know if you want to talk about, if we want to bring that up.
What's that? What are we going to use it for?
We would actually turn this into a list of 5 of these, then we could use sep with space.
Yeah, you know, you're not wrong that would actually help here. So yeah, let's go for it. Let's try it. Little teaser for what more you can do with Python.
So we'll do this thing. We'll say heart. First of all, I'm not going to call it heart char anymore because that's not accurate. We're going to say hearts equals, and then this is going to be a little bit of odd syntax, so it's going to look similar to lists that we've looked at before. But I'm going to say for I in num like this. So hearts equals the Unicode heart for every I in num. So these brackets here, they're creating a list just like we did before, but we're using an expression to actually create a list programmatically. We're saying for every I in num, so from 0 to 4 in this case, 0 to 5, we're going to add this, the heart character.
Okay.
And so at the end of this line here, we're essentially going to have this. We're going to have this in a list. It's essentially the same exact thing.
Very nice.
And so now what we can do is we can say print hearts sep equals the space character because we're printing a list of things. And actually, I think
you're going to print the list, but let's go ahead and see what it does.
I think we are going to print the list actually. So I need to refresh my mind on how sep actually works. But we'll do 5, and then int object is not iterable. Oh, I messed that up. So you can't actually iterate on the number itself. You actually have to call range of num.
So range gives you back the numbers 0 up to 5. Correct. In this case, if you type in 5.
Yeah, it's what's called a generator in that it gives you values every time you call it over and over again. But that's beyond the scope, I think, of this tutorial.
Nice. So now you have a list, a data type containing 5 hearts.
We do.
Right, so what can we do with this now? Because you're printing it out, but we don't want the square brackets or the quotes or anything like that.
So I need to look and see how sep actually works. So Python print sep. I don't use it too often. Sep parameter in print. Oh, I see. So if you actually pass it multiple things in the parentheses. Now, is there a way to unpack? I think there is, and actually I think I might know it offhand. If we were to say print hearts star sep, oh, is that not right, or is it star hearts? Are we not allowed to do that? I think it's star hearts. So first of all, let's test to make sure that works before I. Okay, it does work.
And now we'll explain why it works.
So this star operator is not multiplication in this case. This is actually an unpacking operator. So if you have a data structure, in this case a list, but you want to pass every element of that data structure into a function, like you were literally calling print of this 5 times, like this. Whoops, I messed that up a little bit. But if we were doing essentially that without the syntax error, we can't do that by passing in just the list object because that's just one argument. But if you want to unpack all of the data within the list,
you can explode it into an actual comma-separated list of values.
I think that's actually the term. I think it's called the explode operator, or something like that.
And you can also, or splaying in JavaScript these days. So if you go to hearts 2, can I propose one other approach?
Yeah.
If hearts on line 5 is a list, you can also do this. If you know in advance how you want to separate the elements of any list,
I know where you're going with
you can go ahead and do quote space unquote.
Right.
Dot join, but give me a space between the quotes.
Oh, right, because we're doing it on spaces. We're not actually space separated. So
Join the hearts and get rid of the separator altogether. So now we're not asking for print's help. Instead, we're going to pass to print the result of joining that list of hearts with one space in between. And this way, too, nicely enough, you don't end up, for instance, with an accidental space at the very end that's there even if you can't see it.
Right, and this approach is cleaner, I think, more of a Pythonic way to do it. So we'll do 5, and then we get the exact same behavior, but we've actually made it a little bit, I think, clearer, and we've saved some space in our code.
Yeah, absolutely.
So pretty cool.
So I think we're just about at the end of the hour here, and so what were some of the takeaways we hope? So one, all you need for Python is a text editor, whether it's the one Colton's using here or really any other, and you need Python itself, preferably version 3, which you can download for free on python.org. And then after that, notice that if you've programmed before, there's a lot of familiar constructs. You've got functions, and you've got variables, and assignment, and conditions, and loops, but then you have these fancier features like regular expressions, so powerful, not only in Python but other languages, but also some of these syntactic tricks like list comprehensions, as Colton notes, and a lot of the object-oriented features that we've also touched upon over time. So honestly, I think personally, I would say the biggest takeaway for today should be, please do not be afraid of regular expressions. They can absolutely get scary, but they don't have to start that way. And so if you really do take baby steps and just solve part of your Colton problem, then more of your Ogden problem, and then take care of everything in between, you really can bootstrap yourself, so to speak, to a really impressive solution that you're proud of without having to know what the answer is right off the top of your head.
We have a lot of Colton Ogden problems.
We do. We are so unhappy to see so many Colton Ogdens today, as well as in the chat, I saw Colton's hair.
Yeah, one is too many. Thanks everybody for tuning in. This was pretty fun. Maybe in the future, if we can find the time, we'll do a part 2 because there's a million different things we could talk about. But hopefully this at least whet your appetite for what Python is capable of doing very easily, very cleanly, especially if you come from a background programming in something like C or Java where things are a little bit more less managed for you.
Absolutely. So feel free to tinker. Let us know via various CS50's various channels if you have any questions. But looking forward to seeing everyone again and have a great weekend.
Yeah, youtube.com/CS50, facebook.com/CS50. Check out our content. Cool. And yeah, on that note, have a great weekend. We will see you. Actually, I won't be here next week. I'm going to Japan. But the week after that, I will see all of you. So in the meantime, enjoy your week, enjoy your time, enjoy your break from Colton Ogden, because
unhappy face.
A little bit of that is too much. But in the meantime, I'll miss all of you, and we'll see you in just a couple of weeks. So until then, take care.